Given the accompanying graph of the function f, answer the following. A. Does f have an inverse? Please explain. To determine whether f has an inverse, we can apply the horizontal line test. The horizontal line test says that if every horizontal line intersects the graph of a function f at most once, then f is a one-to-one function. And if a function is one-to-one, then it has an inverse. In this case, we see that if y is less than 0, a horizontal line does not intersect the graph of the function. But if y is greater than or equal to 0, then a horizontal line intersects the graph of the function exactly once. So it is the case that every horizontal line intersects the graph of the function in at most one place. Therefore, f is one-to-one and has an inverse function. For part B, we're asked what is the domain of our function, and also we're asked to estimate the range of our function. Let's estimate the range first. The range is the set of all the y values that are produced by the function. If we draw a horizontal line at y equals -5, we see that that horizontal line does not intersect the graph of the function. Therefore, -5 is not in the range. Similarly, -4, -3, -2, -1, any negative number is not in the range of this particular function. But once we get to the x-axis where y is equal to 0, we see that the horizontal line does intersect the graph of the function, and therefore 0 is in the range. Similarly, any positive number is in the range of this particular function. So our range is the set of y values such that y is greater than or equal to 0. We can also write the range in interval notation as the interval from 0 to infinity. We use a bracket to include the number 0. The domain is the set of valid input values of x for our function. If we draw a vertical line at x equals -5, we see that it doesn't intersect the graph of the function. Therefore, -5 is not in the domain. However, once we get to -4, the vertical line does intersect the graph of the function, so -4 is in the domain. And similarly, any number that is greater than -4 is also in the domain. So the domain consists of all the x values that are greater than or equal to -4. We can also write the domain in interval notation as the interval from -4 to infinity. For part C, we are to, from the graph, determine f of -4, f of 0, and f of 5. Let's start with f of -4. To evaluate f of -4 using the graph, we first of all locate -4 on the x-axis. We draw a vertical line and notice that the vertical line intersects the graph of the function at the point -4, 0. When x is equal to -4, the corresponding y value is 0. So f of -4 is equal to 0. Next, we find f of 0. When we draw a vertical line at x equals 0, that vertical line intersects the graph of the function at the point 0, 2. When x is equal to 0, the corresponding function value is 2. So f of 0 is equal to 2. We evaluate f of 5 similarly. We locate 5 along the x-axis, draw a vertical line, and notice that it intersects the graph of the function at the point 5, 3. Therefore, f of 5 is equal to 3. For part D, we're asked to determine f inverse of 0, f inverse of 2, and f inverse of 3. In order to do so, let's sketch a graph of f inverse. In order to sketch a graph of f inverse, we recall that the graph of f inverse is a reflection of the graph of f across the line y is equal to x. We also recall that if a point AB is on the graph of f, then the point BA is on the graph of f inverse. We've already seen that the points -4, 0, 0, 2, and 5, 3 are on the graph of f. That means that the points 0, -4, 2, 0, and 3, 5 will be on the graph of f inverse. Notice that we just take the x and y coordinates and switch them. The point -4, 0 becomes the point 0, -4. the point 02 becomes the point 20, and the point 53 becomes the point 35. We then draw the graph of f inverse so that it's a reflection of the graph of f across the line y equals x. Now that we have the graph of f inverse, we can determine f inverse of 0, f inverse of 2, and f inverse of 3. To find f inverse of 0, we locate 0 along the x-axis and draw a vertical line. It intersects the graph of f inverse at the point 0, negative 4, therefore negative 4 is equal to f inverse of 0. To find f inverse of 2, we locate 2 along the x-axis, draw a vertical line, and notice that the vertical line intersects the graph of f inverse at the point 2, 0. Therefore, 0 is equal to f inverse of 2. Finally, to find f inverse of 3, we locate 3 along the x-axis, we draw a vertical line, and notice that it intersects the graph of f inverse at the point 3, 5. Therefore, 5 is equal to f inverse of 3. If we compare our answers in parts C and D, we make an interesting observation. We notice that the inputs and the outputs have just been interchanged. In general, if we know that f of A is equal to B, then we'll know that f inverse of B is equal to A.